Okay, now it's time to start with the first speech, organization and concept of EN1998, Professor Philippe Bisch from the EGIS Industries, École de Pont Parité. Philippe Bisch is a civil engineer, graduate of the French École Nationale de Pont et Chaussée in 1971. He is a specialist in structural analysis and professor in charge of various courses in structural mechanics. In parallel, he has spent his entire professional career in engineering, currently in the EGIS group, participating in major structure projects and research works. He was formerly the president of the European Association for Earthquake Engineering, and he is now the chairman of the CEN subcommittee TC 250 SC8 in charge of elaborating the Eurocode 8. He was also involved in the CEN committee. Professor Philippe Bisch, thank you very much, and the floor is yours.
Okay, thank you. So I will share my screen. Thank you. So the contents of my presentation is as you see on the screen. So I will first make a general presentation of all the Eurocodes just to see where the Eurocode 8 stands, and then the links of Eurocode 8 with the other Eurocodes, because in fact Eurocode 8 only complements the others, so it's not independent. I will explain what are the new developments which have been made, and then coming back to the concepts, what are the general objectives, and in particular the ductility requirements and the analysis. Of course, I will remain very general, as you will have all the details in the other seminars. So second generation of Eurocodes. So the purpose of this second generation, I remind you that there is already a first generation which is used since 2005 or 6 sometime, mainly 5. So nearly 20 years ago now. So this purpose is to first satisfy a mandate which is given by the European Commission to CEN for several tasks. The first one is to try to simplify the use of Eurocodes, which is not an easy task, in fact. The convergence in harmonization, in particular, decrease the number of national determined parameters, and also to cover a very long list of new topics over the Eurocodes. And the other objective, which is an objective within CEN, which is to take into account the results of the systematic review. Because you know that in the CEN standard organization, there is a systematic review in principle every 5 years. But this systematic review was not valid for Eurocode 8. It was just made before the start of the work on the second generation, just to mix, in fact, to merge all the comments and take the opportunity of the mandate to make the necessary evolution from first generations. So the first point is ease of use. It is a common requirement in all mandates from the Commission. So there has been a work to detect what is ease of use, in fact. So I just extract a series of ways to try to do it. The first one is to try to improve the clarity in the requirements. Second is to simplify the routes through the code. So it's not only through Eurocode 8, for instance, it's through all the Eurocodes. So how to take the rule in one standard and be consistent with the other ones. Okay. So I remind you that we have approximately 60 standards in your Eurocode standards. Avoid the rules of little practical use, because we are setting a standard for, let's say, normal construction, not for exceptional structures. Avoid alternative procedures, for the same domain of application. We should have, for the same domain, should have only one procedure. And also, as far as possible, to take into account the feedback from users, so from the systematic review. Another question was, who is the user of the code? So there is a clear list, a quite long list of stakeholders, but it is clear that this work is for the design engineer first. So it's these standards, the Eurocodes, are codes for design of structures and also geotechnics. Okay, so the general rule for a standard is to include the state-of-the-art material. So of course, all the recent scientific developments are accepted, of course, but they should be perhaps not worldwide, but they should be accepted by the community in general. So it's not specific to one country, it's general, accepted and validated by experience. So consequence is that we do not cover all the cases. In particular, the very complex cases are not covered by the code. It's not the place for that. And as concerned Eurocode 8, the consequence for this clarification, for this ease of use, is to have a new organization of the code, and I will explain that later. So the way, one side of this clarification is to be clear on the meaning of the requirements. And there was a very important work made on the verbs which have to be used for the development. And in principle, in the text themselves, in the requirements themselves, you will find only these three words. So shall is what we call previously a principle. This is a requirement which is strictly to be followed in order to conform to Eurocodes. And so a principle, there is no allowed deviation. Should is a strong recommendation. Okay, so you may have, in very specific case, you may have deviations, but of course it should be completely justified. So either it is in a national regulation, for instance, for local situation, which is not really covered by the Eurocode, okay, or it may be, for instance, in the case of a rather complex structure, which is not completely covered by Eurocode. In that case, you can justify that you cannot apply such or such rule. Okay, so once again, the Eurocodes are here to cover 80 or 90% of the situation, but not all. So it is, of course, allowed to have some deviation to cover the rest. The last one, the may, is a permission. So you can use this procedure. It is not mandatory, but if you use this procedure, you automatically compile with the code. So we can trust that most often people will use this requirement, but it is not an obligation. Okay, so the consequence of that is that we have to restrict, because we have to apply strictly the shall. Huh? So the shall are real principles, and so they should be limited to very important objective and performances. Now, sometimes we need some information, complementary information, to explain what we are doing and to guide the user. And then you have notes. You have notes where you have this complementary information, but in these notes, you will not find these three verbs. So these three verbs are for requirements, and in notes, you will find facts. Okay, so no requirement in notes, only information. So we have facts, so only is, can, etc. So there is a clear distinction between requirements and information. The second very important point wanted by the Commission is the reduction of national determined parameters, the NDPs. You know that in first generation, we had a lot of NDPs. So the principle to keep NDPs is that they should be linked to safety, because safety is still in the hands of the members. And of course, the best example of that is the partial factors. Partial factors, so you will find, of course, recommended values as usual in the code, but these recommended values can be changed in the national annexes, okay? And in principle, there should not be any NDP linked to physical models, okay? It's not so easy, because to do that, you need to reach a consensus on the physical model, which is perhaps not always the case. And of course, in any case, you have to consider the economy, because this is a local constraint, and this can be taken into account, for instance, in the partial factors. Okay. In the case of Eurocode, so you have in this table, so the organization is not exactly the same. So on the left, you have you have still 6 parts, but they are organized differently. So I've just tried to make a parallel. So in the first column, you have what we have now in the first generation. And in the second one, on the right, you have what is anticipated now in the present state, I would say, in the second generation. And you can see that we have divided by 2 approximately the number of NDP. And we have taken care in AC8 to focus only on the safety aspects and not introduce NDPs in physical models. So I told you previously that the TC Technical Committee 250 is in charge in CEN of development of follow-up first, because it already exists since the beginning in CEN. So this TC 250 is in charge of the development of Eurocodes. So you have the head here of the committee. And in fact, the work is done in subcommittees. So you have the list of the subcommittees. Of course, the name have changed since the first generation. What is new in this second generation? First is this one, SC10. SC10 is in charge of the development of Eurocode 0. In the first generation, it was fully developed by TC 250 itself. So there was not separate SC, but it was decided it is too complicated to work on that simultaneously with the other topics. So it has been separated. There is a new one here, so a new Eurocode about structural glass. So here again, the work is well advanced, and you will have soon an EN on structural glass. Now you have, okay, these horizontal groups already exist since a long time. And now we have these new working groups. So the working groups are here to prepare the future. Okay. So you have one on existing structure, which is very interesting. They have published technical specification. So it's not yet an EN, but the final target is to have an EN, so a Eurocode. So now it is in the hand of SC10 to see what to do with this development by WG2. So there is one on fiber reinforced polymer, one of membrane structure, and there is one which is transversal, in fact, for all, which is a development about robustness of structure. The drafting program, this is the original one. So there were some, so you can see that from the issue of the first generation, which was, let's say, in 2005, there is no so long time before the start of the second generation. And even there was a preparation work which was done let's say, to exchange with the Commission on how to organize the work. So all the preparatory work, which was in fact to prepare the mandate, was done between 2010 and 2015, and the actual work, let's say the main work, the drafting work, was done by project teams during this period in this red cycle, which is just finished now. So what we can say at the end is that the schedule up to this date, the date where we are in 22, it has been followed. So there is no delay in the development here in Eurocode up to now. But at the stage where this was made, it was clear that the situation was not so clear at the end of the process, because now you will have a lot of actions to be held, and it takes more time than anticipated at this time. So what we are here at the red arrow, the first date, in fact, is what we call the DAV. It is the time where the standard leaves the Seine to go to the member states. And so this will be in 26, not 23. You have the last date, which is important, which is what we call the date of withdrawal, where the first generation will not be available anymore. And then we have to use the second one. So now it is anticipated that this will be in 28. So I will not detail everything. This is a program of what we have to do now. We are, if you take the example of SE8, we are in the blue task here. We are preparing the drafts for launching them to inquiry. So you will have a Seine inquiry on all the standards, of course, all the Eurocode parts. Some of them have already been launched. And the second stage, once this inquiry is done, we receive all the comments. The drafts are updated, and at the end, you have a formal vote. So for the approval of the text from the members. It's only a vote without any further comments. Then at the end of this, so you have this date, which is called the DAV. And from this, then the text goes to the national members to develop their national annexes and to update all their regulations, etc. Okay. So what is important for the members is these two tasks, the inquiry and their formal vote, because of course their participation is awaited. Okay, and you have these dates. So the date of the schedule is not the same for all Eurocode parts before DAV, but after DAV, those 2 days are fixed for everybody. Okay, so you have here a list of the schedule for Eurocode 8. So the part 1.1 that we are talking about today and part 5 geotechnics have already been sent to TC250 to prepare the inquiry. So this will take place in the last term of this year. Okay, and we will have the 4 other inquiries next year. So you can see that we are in a rather critical period. Okay, after that, we'll have to, of course, take into account all the comments received and to draw new draft for final votes. So there was, in the first generation, some inconsistencies between the general definitions given in Eurocode 0 and the one that we were using in Eurocode 8. Okay, so this has been, we have tried to align, in fact, to the definitions given in Eurocode 0. And if you look at the definitions we were given in the first generation, In fact, there were not so many differences between what we call the important classes and the consequence classes in Eurocode 0. So we have decided to align. Okay. So here are the importance classes that you have in first generation in part 1. So part 1 is for buildings and part 2 for bridge. Now we will just translate. It's quite the same. Okay, these importance classes in consequences classes, and as there are only 3 consequence classes in Eurocode 0, we are going to divide in 2, which is authorized by Eurocode 0, subclass 333. So which is it says the one with the more importance, the more consequences. So we are going to divide it in 2. So this is a possibility, but for instance, for part 2, we will keep only CC3 without division. So this is a complete alignment, and we have discussed the definitions which are given so that they are completely compatible. The second point was about the seismic situation and the limit states. In Eurocode 0, you have clearly 2 types of limit state to verify, which are the ultimate limit state and the serviceability limit state. Okay, but it was rather different in first generation of Eurocode 8 because you had these definitions. You had no collapse and damage limitation in part 1. You have 2 similar limit state, but with different names in part 2. And in part 3, so for assessment of existing structures, you had another one, which is a real linear collapse, which was added. So you can see that it was not really very consistent, but of course it was explained by the calendar of the development of the different parts. So now what we have done is to try to completely comply with the rules, the general rules given in Eurocode 0. Okay. So we have also add another limit state which is operational. So you can understand what it means. It means it may be used, for instance, for critical installation in hospitals or things like that. Okay, to assure the operability of the service during, of course, a given level of earthquake. So this has been added, and we have classified the limit states, so retaining the 4 that we have now in these 2 series, 2 families. The 2 first ones, so near collapse is mainly for existing structure, significant damage, and this is more convenient, as you will see, as the name, the one which has before named no collapse. So now it is significant damage. Then this one is used for new structure. And you have SLS, so serviceability limit states, for damage limitation and operability. And a consequence of that is that there were some verification in damage limitation in first generation, which obviously were dedicated to safety of structure, and these have been removed and, of course, rewritten in the form of ULS. In the different parts that we have, the verification of one ULS at least is mandatory. Of course, the main aim is to assure the safety of the structure and then of the people. But the choice of SLS, now it's open. It can be for certain types of structure in the national annex, it can be in the contract. It is only, you will have the technical rules which are developed here, but it is up to the authority or to the contract to decide whether they make this type of verification or not. So what is new in Eurocode 8? The first important thing is that we have, in order to have a more clear organization, so we have changed, in fact, the contents of the parts. Not all, but so the new organization is that one. Another target was to avoid to have repetitions. If you look at the present parts 1 and 2, so between buildings and bridges, you had repetitions and even sometimes inconsistency. But it was very important that all the rules which are common to all types of structure are in the same part. So you have a general part where you will find the description of the seismic action, and you have the general rules of verification and of analysis. So everything is there. And of course, all these general rules will not be repeated in the parts dedicated to structures. They will only be a reference. Same, all the general rules which are linked to geotechniques or foundations are now in part 5. And so they are also common to all types of structure. So the second stage is for design of new structures. So you have buildings, so which is now separated from the general rules. You have bridges, as before, and all the other structures have been merged into one single part, which is now part 4. Okay, and now you have part 3, which is the same. The objective is the same than previously. It is to cover the assessment of the existing structure, but we have included bridges in this part. Okay, so a small list. It's very limited, just the main points of content included now in the scope Eurocode dates. So the verification of the operational limit state, the development of the displacement-based approach. We have a complete development of the structure equipped with anti-seismic devices, not only base isolation as before. So there was a request from the Commission to have an harmonization about seismic zonation. So this is an important point which will be detailed by Pierre Labbé later. Soil structure interaction has also been developed, ancillary elements in all structures, in fact, not only buildings, flat slab system in buildings, infill frames and claddings in buildings, aluminum structures in buildings, bridges in part 3, so for existing bridges, timber structures in part 2 for bridges, and part 3 for assessment of existing structures. So you can see, of course, there are more, but okay, here you have the main ones. But you also have changes of what exists already. So you have a long list of things which have been improved. So first one is about the seismic zones. You have an homogenization of the definition of the seismic zones. The simplification of the global safety choice through the seismic action classes. So you will have detail on that. A unified way of deriving the resistance partial factors on material. A better definition of site classification. So you will have also the details on that later. The redefinition of the elastic response spectrum, which is now based on 2 parameters instead of the ground acceleration, and the spatial model of the seismic action. You have a new definition of the ductility classes. Okay, you have 2 equivalent approaches for the analysis. You can use the force-based with the Q factor or the displacement-based. You have several improvements on analysis. You will see that later. You have the better definition of the non-cyclic, non-linear cyclic constitutive laws of materials, and a better control of drift and second-order effects. So coming to the general objective of the code, okay. So you have this in your introduction, although it is in the introduction, so it is not mandatory. It is a good explanation of what we are doing. So by nature, a perfect protection against earthquake is practically not feasible, in particular because the knowledge of the hazard itself is characterized by a significant uncertainty. Okay, so what is important here? Therefore, in Eurocode 8, the seismic action is represented in a conventional form, proportional in amplitude to earthquakes likely to occur and representative of their frequency content. This representation is not a prediction of a particular seismic movement. Okay, so this is important. You know that when we introduce the seismic action, it is not a real earthquake, it is a representation of the earthquake. Okay, now there is another point which has been clarified because it was not always the case. Eurocode 8, as all Eurocodes, is a purely technical text. Safety is in the hands of the members. So we have to explain to the members what are the tools to be used, but we don't take their place. So it is purely technical, and we have tried to clarify this in all requirements. So the performance requirements have not been really changed, and you know them. Human lives, damage, and facility, important for civil protection, operational. The design principle, verification for new structures, so verification of the SD limit state. So it is mandatory for new structures. To ensure deformation capacity and cumulative energy dissipation capacity. So this is, of course, important in all types of structure. And of course, avoid brittle failure and unstable mechanism. So you have a description of limit states. I will not enter in that because we are late, I think. Okay, so you have 4 definitions of the limit state. The objective of that is just to describe to the user what is the state of the structure which is awaited at the end of the earthquake. So it's not a commitment, it's just a description to describe the target. Okay. So you have 2 safety choices for buildings. I think it will be explained in more detail by Pierre, so I will go rapidly on that. So you have 2 ways to define these safety shocks. It is either by the return period, and it depends on both the consequent class and the limit state under consideration. So it's no more an importance factor. Before you have importance factor, now you have this approach in return periods, or the other one. So this choice between both is made at the national level. You can use these performance factors, which in fact look like the importance factor that we had previously, but you can see that they are much more detailed. This is a safety choice, so the seismicity index. So it will be explained in more detail by Pierre. I don't enter into detail, just to say that in the definition of the seismicity index, you have a part which is only due to the seismic action. So let's say it is physical, and the choice which is given to the member is about this value of delta, which depend in fact on the consequent class of the structure. So it is a global way for a given type of structure. So the values of this delta is for each type of structure. And once this is chosen, then you have to refer to this table, which is fixed, and to classify the seismic action into seismic action classes. Okay. So once again, this is a safety choice, and it is not the same that the classification of seismic zone, which itself is based only on seismic action consideration. So I will finish with this important topic, of course, of ductility requirement. This is important because we have redefined the ductility classes, so that you know already. Yeah? So you know the principle of that. We should ensure the post-elastic behavior of the structure. So the objective is to locate the plastic zones in the structure and to eliminate the brittle failures. So this is done through a procedure that you know, which is capacity design. Okay, but we also have to improve the ductility of the plastic zones. So this is local, the capability of plastic deformation. Of course, this depends on the type of structural material, but it's mainly about the size of squash section geometry, and also for detailing, mainly in the case of reinforced concrete. Okay. Now we have always to choose between strength and ductility. If you use a low value of Q, you have a higher strength, and on the contrary, if you are using a high value of Q, you need a high ductility. Okay, so there are, of course, some consideration of cost between this choice. Now, what to redefine the ductility classes? It is, I would say previously you had 3 classes, L, M, and H. Let's say M and H were based on the same concepts, except that H was based on more stringent rule, and the observation, so this is a feedback, was that in fact DCH was not used very much. So this has led the decision to try to do something else. And this is based on the consideration of seismicity areas in Europe. If you look at seismicity maps as this one, of course, you know that you have countries in the south with a high seismicity. So for them, you need a high ductility in principle, but you have a very wide range of intermediate seismicity. So from France to Turkey, where you may have, let's say, moderate seismicity or low seismicity. Okay, this is also the case of part of Norway. But in the rest of Europe, in the north, you have very little or null seismicity. So what we have tried is to adapt the ductility class, mainly DC2 and DC3, to this situation. So DC3, of course, can be used everywhere. It is a class with high ductility. Okay, when we assure the ability of the structure to form a global plastic mechanism. So it is a global behavior of the structure. In DC2, so DC2 aims at covering all the intermediate seismicity cases. Then you have a more local approach. So the local deformation capacity is assured, okay? And there is some overstrength, okay? So the definition is different and the practice is different. Another thing is that we have done is to make the decomposition of the Q factor in 3 parts. The first one, so what is called QS, is the overstrength. It is the one that we are using in DC1. So DC1 is similar to DCL, okay? And this has been fixed at 1.5. We don't want to have discussion on that. It can be, of course, basically discussed, but we have decided to fix this to avoid conflicts on that. QR is what was called before alpha U and alpha 1. So it represents the hyperstaticity, the redundancy of the structure. And QD is directly linked to the ductility itself. So it is the length of the plastic range. Okay. So you have here the comparison between, let's say, a pushover and a Q factor approach. Okay. So for that, in each material, you have the values of the different components. So QS is always 1.5. So you have here QR, which is similar to, once again, to alpha U to alpha 1, and the value of QD, which depends only on the ductility class. Of course, QR does not depend on ductility class. Okay. Second question is that now you have limits. But the limits, you remember that for DCL, it was recommended to use it only in low seismicity, but it was not reasonable because obviously the use of DC1 depends on the type of structure. So the limits have been differentiated according to the types of structure. The second point is that as DC2 has been developed for moderate seismicity, so now you have a limitation in the use of DC2. And of course, this depends on the type of material. The verifications that you have to do, of course, they are the same than before: equilibrium, control of second-order effects, limitation of interstory drift, verification of member stability, so local stability, so the capacity design for DC2 and DC3, and the verification of resistance, which of course depends on the type of material. For the force-based approach, of course, it is based on the other Eurocodes. Now for the verification in the case of pushover analysis. Okay, so you have two types of resistance. If it is a ductile mechanism, you can see, so it depends on whether it is a rotation or an elongation or global, whatever it is. Delta is a parameter which defines a kind of deformation. Okay, so here you have the elastic deformation, and here you have the plastic crunch. Okay, so you can see that we at SD, so significant damage, we have a coefficient here which place the target point, let's say somewhere on the plastic crunch. Let's say alpha, it's a physical choice, so it is between 0.3 and 0.5, let's say. Okay, so we are in the middle, approximately in the middle of the plastic domain. And above that, of course, you have a partial factor, which is here is NDP. For the brittle mechanism, for instance, shear in reinforced concrete, then you have, of course, the direct verification to shear resistance with partial factor. Okay, so I think it was long, but you can understand that there are many questions in your codes of interest. Try to make a synthesis of this.
Okay, thank you very much, Professor Philippe Bisch, for your very detailed presentation. You have been able to sum up all the measured changes, so we're very grateful for your presentation. I can't see any question in the chat. Ricardo, do you see the same?
Yes, I do confirm. So far, no question has been posed. So
okay. There are no questions, but if you prefer to make questions even by raising hands and speaking, of course, is not forbidden. Meanwhile, well, there is a question by Fabrizio Paolacci, Roma Tre University, chair of the working group 13 of the EAEE. The question is, limit states are related to the structural performance of the structure and structural members, whereas consequence classes are related to the effects of a given limit state exceedance. What
Yes.
about the non-structural elements? To be clear, a limited damage in a non-structural component of an hazardous plant, pipe rupture, is generally considered limited, but could cause a serious consequence. Is
Okay.
this aspect clarified in the new generation of EC8?
Yeah, I think so. So you have. I will come back to these definitions that I didn't have time to present. Excuse me, I'm just trying. Okay. So first, I will say that now in part 1.2, so for buildings, you have a complete chapter dedicated to ancillary elements. My first observation is that we call them ancillary elements now because there was a debate within CEN because there are existing standards on on some non-structural elements. So to avoid any confusion, we have renamed them ancillary elements, which means the elements which are attached to the structures. Okay, we are covering only those. We have a complete chapter for the ancillary elements for buildings. We also have one for the industrial structure, for instance, or taps, etc. So it has been introduced everywhere. And honestly, the new chapter that we have in buildings now, it's much more detailed. Now, as concerns the objective of that. So if I come back to that I didn't tread, you have the target, in fact. Huh? So for near collapse, once again, this one is mainly for existing structure. LS of near collapse shall be defined as one in which the structure is heavily damaged with large permanent drift, but retains its vertical load capacity. Most ancillary components where present have collapsed. Now, significant damage. So this is for new structures. Significant damage shall be defined as one in which the structure is significantly damaged, possibly with moderate permanent drifts, but retains its vertical load-bearing capacity. Ancillary components, where present, are damaged. Partitions, infills have not failed out of plane. The structure is expected to be repairable, but in some cases, it may be uneconomic to repair. Okay, so you can see that in this definition, once again, it describes an objective. Okay, and for this objective, you also have the description of the behavior of the ancillary elements. Okay, and of course, of the technical developments which are made after, so which are purely technical, mainly in this new chapter. All these developments are aimed, of course, at respecting these general targets. And you have also two descriptions for the limitation. I didn't reproduce them here, but you have two similar definitions for DL and OP. I don't know if it answers to your question.
Okay, thank you. There is another question by Andreas Nielsen from Atkins. I note that the introduction of greater granularity in the return periods and the performance factors.
Yeah.
Are the two parameters not really about the same issue, i.e. probability of failure or reliability? And if so, why have you chosen to specify the reliability in terms of two parameters when only one could be sufficient?
No, it's not exactly so. What we have seen in first generation, so you had the importance factors in the first generation, but it was much less detailed than that. Now you have a complete table and depends on the consequent class and the limit state. Okay. So this is what was used by members with, of course, sometimes different values for the importance factor. But some countries, for Portugal, for instance, have changed that and have used the return period. So what we thought, it was convenient to offer to the member the possibility to use both. So of course, they will make only one choice. So it should be in the national annex, where the national the member choose between using the return period or the performance factor. So it is really I would say the feedback experience. It is the observation of what exists now in the national annexes. Okay. Now, as concerns the content, it is completely open to the choice of the member because it's completely safety. So you have recommended values. They may be different for buildings and for bridges, for instance. So this table are in the relevant parts, but you only have recommended value. Now there was another consideration. The first generation already exists. So we have received comments from the from the review which has been done within the member from the inquiry. Okay, but we are not supposed to change values which were already accepted by members. So we have used on one side return periods, which are recommended here. We have given performance factors, but we have tried not to deviate too much from the values which are given now in the first generation, because it was not a request from members. So there is an attempt to be, let's say, consistent, but it may be not exactly consistent because you have two different approaches which are separated.
Okay, there is another question about the Eurocode 2 from Sébastien Selamain, Socotec, France. The AC2 is equally updating. Do the evolution of the Eurocode 8 will be linked with the Eurocode 2 about new materials? For example, an aspect is about using recycling granulates for concrete, for construction. Another example is lightweight granulates. What aspect will be taken into account in a part of Eurocode 8?
Okay, so I know the problem. The problem that Eurocode 8 has is that we had to develop the code in parallel to the development of the other Eurocodes. Okay, so there is a problem of timing, but it was your original choice, and we have to try to take this into account. So what I can tell you is that we have a very strong relationship with the other SC chairman, and in particular with SC2, but it is clear that we cannot cover exactly the same thing. It was not, I know the problem exists, this problem of lightweight aggregates, etc. I'm not sure that we can cover it in this draft. Perhaps what we can do in the future to introduce them through a technical specification. Okay, but probably we will not have the time. So the problem exists. You have the lightweight aggregates, but you have also some other types of use. For instance, reuse of existing aggregates, etc. So we should try to do something, but I am not sure that we will be able to do it in this draft. So once again, it can be done after. But what should be considered is that when it is not covered, because your code is not supposed to cover everything, as I told you before. Okay, so if it is not covered in your code, then it is perfectly permissible to have documents in the member states themselves.
Okay.
The harmonization is only for what exists. You understand? Okay, but what can be done at the AC8 level is to develop in the future technical specification to cover all these specific situations.
Thank you. Thank you very much, Professor Bisch, for your answers. There are some more questions, but I think we are at the 10:15, so it's convenient to move to the next speaker. However, the chairs of the sessions will be collecting all the questions and forward to the speakers in case they want to answer to all the raised questions by the audience. So I thank very much again Professor Bisch for this first contribution to the first webinar, and I ask Ricardo to introduce the second speaker of the webinar.